share my screen. Okay, so I got a confirmation that my screen's up and good.
It is good. Yep.
Perfect. Thank you, everyone, for joining the webinar today. Like Rick said, my name is Mike Hartington. You can find me online at mhartington if you would like to tweet me pictures of your animals or just ask questions afterwards. We're going to be talking about building cross-platform apps, and we're going to be talking about doing that with Capacitor in Angular. This is a topic that is very near and dear to me because I work in this stuff on a daily basis. So let's start off with setting some baseline, right? I think we all are aware that mobile development is not the easiest space to be in. Depending on what approach that you try to take at building a mobile app, there's oftentimes a lot of complex tools to learn. If you are looking to target iOS and Android, well, these are platforms that have very different design languages and design expectations and or user experience expectations. So you're not necessarily building something that is going to work the same exact way when you are building with native development tools. If you try to build with these native development tools, well, now you just kind of signed yourself up for maintaining both of these platforms. And at the end of the day, we're missing out on this huge chunk of users that are accessing information out there through the web. So native mobile development, very difficult, and it only gets us so far. So when I started off doing cross-platform development or just development in general, I think a lot of the main goals I want to have was just to reuse my web skills. At the very beginning, I wouldn't consider myself a JavaScript expert, but I knew enough to get myself into trouble and then be able to get myself out. So I didn't want to have to go through that learning process all over again. So I want to reuse my skills and be a effective web developer that could also build for native. Again, I didn't want to. I was a new developer, really. I didn't want to have to maintain so many different projects or even really learn a lot about these native platforms. So if I could have just reduced the amount of code that I need to maintain or that I even need to write, that would have been great. And end of the day, for everyone, I think the faster we can get something out the door and shipped to our users, I think we're all looking to do that. So whatever we can do to reduce our either time to market or reduce the development cycle, making sure that we get features implemented and shipped quickly, that's all important. So whatever we can do to reduce that time to hitting deploy, let's try to hit that goal. Now, if you've heard me speak before, a lot of this stuff kind of sounds familiar, and that's no secret. I've been involved with this space for quite a bit, and I think you're all at least slightly aware of what I'm going to be talking about. But I want to set the stage and kind of reframe how we talk about cross-platform development in this kind of way of rate once, run anywhere, and reframe it as not about technologies or approaches, but about levels of abstractions. In that the technology choice that we make and the technology choice that we're going to look at today, it's less about write once, run anywhere, or any of the technical aspects of it, but more about being at that right point of abstractions away from any given target. And the best way to visualize this is by comparing going in a pure web developer friendly approach and then a pure native approach, and seeing how, if we take steps away from those approaches, how do they compare and what are some of the details that we need to know? So keep this graph in mind. And let's kind of dive into the first one, which is this Cordova or phone gap. So if you've heard of this name before, you probably have heard it from a talk from mine or from various talks online. But Apache Cordova, it is probably the original pusher of write once, run anywhere. And their whole idea was that there was a group of web developers who wanted to take part in shipping web apps or writing apps for mobile devices. Originally created around the initial release of the iPhone, they wanted to take part in this whole app marketplace, but they didn't want to have to learn how to write Objective C or even Java eventually. They wanted to just reuse their web skills and deploy to the App Store. And a lot of that comes through in the implementation and in the actual approaches that you use when you work with their technology. Now, their idea was that it was to polyfill the web browser by giving you access to certain features and APIs that didn't ship yet. So things like the camera, file system, geolocation. At the time, those APIs did not exist on the browser. So this was a way to prove those APIs out, work closely with the spec and the standards to implement them in a way that would be very future friendly and follow the spec to a T. Eventually, they didn't really get to that point, but that was the original goal. Now, just a quick little sample code for this. We have this concept of navigator dot or some global reference to an API. In this case, we're looking at the camera API. It's attached to the global navigator object. So if we want to say, take a photo or bring up the native camera UI, we could just say navigator.camera.getPicture, pass it a success and a fail callback, and then set some options for when that camera API gets called. So in this case, we're just calling camera.getPicture. My success will set some image data that gets returned. On fail, we'll get a message or a reason for why it failed. And I want it to be a pretty low quality image. And I want to get a data URL, which would be like a base 64 string versus a actual file reference. So all of this would just let us call that, and we attach a click handler, and we pretty much have have access to the camera right away. Now, things to note: this navigator.camera.getPicture, it's not necessarily a standard API. There's no camera object available on the browser without Capacitor, without Cordova being involved. So this becomes a little problematic right off the bat. We have to make sure that we are constantly using Cordova and that we constantly have access to this, or that we have to conditionally code around situations where Cordova is just not available. So camera isn't the only API that we could have access to. We could also have access to things like I said, the file system, geolocation, a built-in in-app browser, and this huge community of plugins or APIs that were provided through this plugin architecture. Now, on that subject, the plugins and the platforms that you could target, all of these things were kind of published before NPM Yarn, before we have like a standard idea of what a JavaScript package should be. So most of these were kind of shipped with this very custom and very, I wouldn't say proprietary, but this non-standard approach to adding packages to a project. Ways that just didn't stand the test of time with the onset of NPM, Yarn, and having things stored in a local node modules directory. And that to me is also a symptom of, a very fragile ecosystem. They had a very custom package. They had a very complex build release cycle. They had kind of iffy plugins that were available some of the time, not all the time. So right now, I don't really recommend people using Cordova, but even so, at the time, it was still pretty quirky. You weren't really following the standard web flavor approach to doing things. in addition to that, they really tried to push that polyfill approach to web development, where their hopes were to follow the web standards as close as they could, but the standards kind of kept moving and support from the community just wasn't there. So we would see things kind of uh, mm, we'd see things kind of get stagnant. So APIs like the media devices API were never really fully adopted into, say, the camera API provided by Cordova. They really wanted to push this whole no need for a native IDE or native tooling. You would just do everything through these command line tools, which was great in theory, but had some pretty, I wouldn't say bad, but has some unforeseen consequences. Most people who have worked with Cordova before have run into the dreaded error code 65, which sounds pretty scary, but really all it is just the project wasn't signed by the right certificate, so you can't necessarily deploy to the right platform or to the right device. All that would have been solved by just opening the native IDE. And also, they took the idea of native projects and really pushed them as a disk target or a build artifact. So if you were trying to build something, you had to set up your signing certificates. So it's working great on your machine. You commit it to version control. You've lost all the native project configuration. There's no way for your coworker to clone that project, install it without having to manually apply those changes to the project. So it's kind of a very volatile setup. So this is one approach to doing cross-platform with Cordova. What about the other side of the spectrum? Remember, this is kind of one step removed from doing web development. What's the one step removed from doing full native development? And that's these compile to native approaches. There's a few different solutions in here, but they all kind of provide this idea of what if we had an abstraction on top of native development that was closer to native development, but brought in some either web goodness or JavaScript or just some third-party language to really mix things up. And they kind of pioneered this idea of either learn once and write anywhere, or don't use JavaScript or use some kind of other language to build your app. And they all kind of come with this promise of a quote unquote truly native app. This is a bit of a marketing term of a truly native app, as we will look at later, but they promise a truly native app, native performance, what have you. And they bring this idea of a standard kind of API or standard wrapper around native controls, native device features, basically removing the need for you to ever write or learn native languages or native features. So from like a 10,000 foot view, if we think about what this actually looks like, we have your app written in this in this blue text or this blue box up here, where we have that loaded up in some kind of runtime. Some approaches use things like V8 on Android, JavaScript core on iOS, or a fully custom fully custom renderer / virtual machine that interprets your code and handles all the communication between your native device features. But typically there is this renderer or runtime wrapper, this bridge layer, and then this communication channel between OS level features, hardware features, and this kind of pub sub architecture where they would make calls from the wrapper, from your app to the wrapper, to the bridge, and then serialize them back. So this is not, it's a very, very simplified overview, but it's a pretty similar approach across the board. This kind of breaks down, though, because we are now having to relearn a specialized version of the tools that we're already used to. some of them tell you that you can use just JavaScript, but then you are limited to what approaches that you can use. For example, you might not be able to use the same elements and divs and H1s, paragraph tags that you're used to using in the web because those concepts don't exist in that platform. Some languages or some approaches say JavaScript's not the right language. Let's use other languages altogether, which is a really hard sell to a web developer, in my opinion. Now, in addition to that, we also can't reuse any existing web code or any existing project code that we have maybe developed in like a prototype or whatnot. You basically have to rebuild that all from scratch. And if you specialize or if you depend on, say, like a specialized library or third-party package, you're going to have a hard time trying to find one that exists for these platforms. So if we were to say need a Canvas API, we're going to have to find a package that is specific for these targets versus just saying, oh, I can find a Canvas API on npm, and there we go. I can add it to my project, and it just works. These projects, these type of approaches of compile to native, don't necessarily bring the benefit of what web development can give you. So you're isolating yourself into this very specific silo. And this truly native kind of pitch is a bit misleading because the idea is that I think people try to read this as, oh, my code gets compiled away and I get this very highly optimized native binary, right? And that's not necessarily the case. In some approaches, you get the JavaScript that you write, and that is just translated and loaded up, like I said, in a VM, so no V8 or JavaScript core. That JavaScript is still there and is still executing. It's just rendering all the controls that you need to show to your user on the fly. So if you write a very slow loop, or if you have this very computational heavy bit of JavaScript, well, that could affect your performance, and there's no way to really get around that. Other approaches where they say it's a truly native app actually implement all of the controls through a very custom renderer that doesn't use any of the native controls. So you basically are drawing a canvas on your entire screen, and it's up to that platform to make sure that their code matches the native platform code. Not necessarily something that I would consider, truly native if we're having to recreate all this stuff. So these kind of approaches, they leave a lot to be desired. Either some of them are too much or some of them are not enough. What's the kind of sweet spot? Like I said, Cordova and PhoneGap are like one step removed from doing pure web development. These compile to native approaches are at least a step removed from doing pure native development. What's the middle ground where we can get the best of native abstractions and the best of web abstractions? To me, that's Capacitor. Right there, it solves a lot of problems that we saw from both the compile to native approach and the PhoneGap Cordova approach. So, in a real simplified way to explain it, Capacitor is two parts: a native runtime and then a JavaScript library. It gives you a native shell that you can load up into your project, and then it will load a web app, the web app that you write, and give you access to device features. It exposes those features to a JavaScript library that you can import and install through npm. Now, this JavaScript library and these APIs are adaptive, so that way, if you deploy it to a website or as a progressive web app, you're going to get the web version of that implementation. But if you deploy it to an iOS device or an Android device, you're going to get the correct implementation for those platforms. And the way it achieves this is by making sure that it can utilize the correct native binaries and native features that each platform provides. So to get certain features added to iOS, we're using things like CocoaPods, and for Android, we're using Android libraries. So nothing here is custom tooling or custom implementations. We're all just making use of things that already exist on these platforms. Now, big 10,000 foot view. We have our app again in this blue square, and that gets loaded by a native web view for each platform. So this is WebKit or Safari on iOS, and then a Chrome web view for Android. When the app is loaded, there's a connection layer to a bridge, which will handle calls out to the device features and then serialize that back into your web app. Not too dissimilar from, say, a compiled to native approach or even from a Cordova approach. What really sets it apart from all this is how how you get a web app out of this. So you're bringing in your existing web apps, your web technologies, your web developers. Everyone can contribute to this because it's just loading up a glorified web app. The native runtime is instant, near instant. When you create the app, the web view is already loaded. It already knows how to communicate back and forth with the bridge. So there's a little to no delay in getting access to that code. If you're running a fast app and you can load and bootstrap your app very quickly, you have access to those native features. Kind of offsets the expectation of, is it the approach that is slow or is it my web app? The approach is very fast because it's all done natively. The web app just needs to be as fast to be able to catch up to that. And then it utilizes the best practices from native. So if a new version of Android Studio or Xcode comes out and provides some updates and changes, we can take advantage of that and know that it's not going to break our project or cause a significant amount of errors. Because we're following the best practices and following the recommended approaches for building native code, your apps are going to be able to take advantage of incremental updates as the platform moves forward. So kind of enough yammering. Let's kind of look at how we can add Capacitor to a project. So I have this Angular app running right here. I do use Vim, so you're going to see a lot of Vim. I apologize in advance, but I can't get used to VS Code still. But we have this app right here where all it's doing is loading up different notes as I've been trying to get better at keeping notes and making sure that I'm writing things down. So I'm going to create a new note. I'm going to call this hello webinar, talk about app, go demo, close slide. And yeah, it's just using a rich text formatter, using this project called Quill.js. If you haven't used it before, check it out. It's pretty awesome. But I have this note right here. I'm just going to save it. And hey, I had that showing up in my my list initially. I have my grocery list where I am loading up, say, the bread I need to get, milk, eggs, and coffee. I made some changes so I can save that. All of this under the hood is using Capacitor. It's using its file system API. Now, to get this into my project, I ran two commands. First, I did an npm install at Capacitor core at Capacitor CLI to install the necessary dependencies. Now, this core just gives you access to a standard kind of interfaces that you can get to throughout the project. And the CLI is just a per project CLI that you can use to interact with Capacitor altogether. if I wanted to instantiate this project as a fresh new capacitor project, I could just run npx cap init. Now this will ask me a few different questions, like where is my disk target, or where is my web code getting built to? What do I want to call the package or the project? What's my bundle identifier, which is pretty important in native development. Basically, tell me a little bit about this project, and I'll give you something. If we were to say go back and look at what that creates, in this case, we have this capacitor config.ts. So this is making use of a TypeScript-based config file, so that way we can have some dynamic values being added here. But we can say if I'm my app ID for the bundle identifier is this com.example.app. It could be a few things. This really matters for the assigning aspect of your apps. That way, each one has its own unique identifier. The app name. So what does the actual app show on your device once it's installed? My web directory or my build location is going to be in dist ng note taker. And do I need to bundle the web runtime? No, because I'm using things like Angular CLI to do my building for me. This is really only useful if you are not using a framework and you're rolling your own solution. From here, we can come into this homepage, and inside of the actual homepage component itself, we're making use of Angular material here, where we're just loading up this common app header, giving it a button to add to our header. And then we're using this material list item to iterate over a collection of notes and to just render out the name of those notes. So the home component for this is actually using all of Capacitor to load up files from a file system. So we're making use of this package called Capacitor File System. It's just another NPM package that we can install into the project. And then we get access to stuff like the file system API itself, a directory enum, so that way we can have some standard and type-safe access of different file locations. This reader result, so that way it's just a type and we can type our methods and have some good auto-completion. So on init, we're just going to say, hey, file system, request access for this. So if I go ahead and I load this up on a platform and I have said no to reading or writing files before, it'll still prompt the user like, you sure? Can we please just write a file? We're going to write it into this one sandbox location. Can we please? Request permissions will handle that for you and just give you the either handle, say, yep, you can request permission, you can get access to that. And then once that's done, we can just say, all right, init the file system. Now, init file system is this long promise of we're going to make a directory, no op from all the success and failures. Once that make directory has succeeded, we will just say, read all the files in that directory. And then once we've gotten the files off of the results, we will just set the actual notes to be an ordered version of them, where we are basically just organizing them by that final digit, which is just a timestamp. The real details here are the make directory and read directory, which are just returning promises. So all of Capacitor's APIs are asynchronous, so we can implement them in a very friendly asynchronous way. This is a promise. We could do this as observables as well by just wrapping this with a from. But for my needs, a promise works pretty well. So I'll read this directory. It'll be a path called notes in the directories.document, so a document-based location. And makedir will do the same thing, just calling file system.makedir. So pretty clean API. And well, what else do we have? on here. So we'll go to the file system itself. Well, we have a few different methods that we can use. We could append a file, we could get a file URI, delete, make a directory, delete a directory, get even the stats on that. So what kind of file does this file exist even? What are some of the data? What's some of the stats on this file? So it's heavily influenced by some the Node file system API. So if you've used that before, it should feel pretty familiar. Now, once this is all set up in place, we come over to our note taker or our edit note page, and we just load that content up. So in the edit page, we have all of this being loaded up. We can ignore this modules part. This is just for Quell.js to set up the toolbar. But we come into here, we just grab the router ID from the parameters. And if there is a route ID on init, we're just going to read that file. So say file system.read file, pass it in the location, set the directory and encoding to return the results from. And then once that data has been returned, we're just going to set the content of our editor, our new editor, Quill editor instance to be that data. So this is just using things like ng-model to bind the value. So we have a really nice approach to reading file data and setting it somewhere in our app. If I make a change, well, I'm just saying, hey, does this file already exist by reading the route ID? If so, the name of this file is going to be that route ID. Otherwise, generate a note, a new string where I'm saying note equals date.now, and then append the .txt extension to it. So fairly simple here. From that, I can await writing this file. And then once that file has resolved, I can just go back. So as we saw here, all right, it's my grocery list. This is my shopping list. I'll hit save, go back to it, and cool, it's already there. What's even better here is if I want to say delete a file, it actually would be quite simple to do. So what I'm going to do is add that real quick. So I'll say async delete, and I will just say const file equals this dot route ID, and then if file, I will await file system dot delete file, passing in the path to be my notes directory, and then the file name itself. And then the directory is going to be the directory dot documents. And you can see the list of locations and where you can store your files, whether it's in cache, documents, external storage, data directory. All these are just kind of provided by the file system. So we will say, all right, delete the file, await for that result. And then when that's done, we'll just say this dot go back, save that, go to the edit page itself, and then on our button, we'll just say click equals delete. Double check that compiled successfully. Cool. So let's see, we'll go to our hello webinar. I'm just going to delete this. See what went wrong real quick. Oh no. Well, we did say that this is this is a demo, so we can kind of move on from it. If any of you eagle eye viewers out there can notice what's wrong with this, please let me know. That would be great. Bring it up in the Q&A. But
saying that
let's
you
go ahead.
Save and not delete. Maybe try that.
Oh, that is right. There we go. I just hit the wrong button. Thank you so much. I'd say that's embarrassing, but I've done my fair share of embarrassing things as a kid, so I can take that.
It's always during webinars anyway. Like if anything could go wrong with your code, it happens when you're presenting it. So
just happens to work out that way.
It does.
Well, with that in place, we have our app running. This is just a web app, right? Nothing about this screams, I'm writing a native app. So let's go ahead and actually add that stuff. So what I'm going to do is actually just come over here to my terminal, and I'm just going to do a quick little build, passing in the production flag to do a prod build. This is a pretty small app, so it should go pretty quickly, but this will give me ample coffee time. So nothing what we're doing right here is too far out of the expectations from what a web developer should feel comfortable with. We're just building our web app, kind of letting it do its thing. Took a little bit to get done, but fairly small app. Let's go in and let's say deploy it to iOS. So I'm going to run npx cap add iOS. So this is going to add a full native Xcode project for me. It's going to copy the assets from my build target to the native project. Now, what you can see right here is that they found one capacitor plugin for iOS. Again, this is using CocoaPods to manage plugins. So it's going to install the plugin for that and copy it over to our project. Now we get some little feedback here after the update and the add have run. So we can do npx cap open iOS and open up the iOS project here. Now, if you're afraid of Xcode, don't be. It's like Apple Music or iTunes just for native development. But note that we have this app folder over here, which holds our native project. So I can come over to here and load up a Swift file, which it doesn't look too dissimilar from JavaScript. So that I should be pretty familiar with. And then I get this pods folder, which shows me all of the different pods or plugins that are being used for my project, all managed through native tooling that is found in a native iOS developer's toolchain. So my app is ready. I have it selected to target an iPhone 12. Let's go ahead and hit this run button. All right, I think hey, here we go. The app is loaded when iOS decided it wanted to load. Let's go ahead, we'll create a new note. I'll just say, hello from iOS. Save that and go back, and our notes still load. So we have a really good system of loading notes, and these are saved to our actual file system on the device. So this is looking pretty good for an iOS project, and I won't go through the hassle of trying to do Android, because if we think iOS was slow right now, Android would be even worse. So let's kind of go to the slides again and just kind of wrap up what we did here. So if we had an existing web project and we wanted to add Capacitor to it, all we could do was just run the npm install command for the Capacitor core library, the Capacitor CLI, and then run npx cap init. This will give us all of the configuration for a fresh project. And then if we want to add different plugins or platforms, we install them and run the appropriate command for that. If you want to know more about the commands and the different settings that we have available, well, you can go to capacitorjs.com, capacitorjs.com/docs to learn more about the project itself and the different CLI and APIs that are available. Also want to point out that we have this new community organization that we've been trying to grow. It is a place for
developers to share third-party APIs and plugins under a curated list for things like sign in with Apple, in-app purchases, SQLite storage, various different APIs that don't necessarily make sense to be part of core, but we want them to be there, and we want to have some kind of way to help developers add them to their project and make sure that the code that is being used there won't get stale and is following best practices. Now, Capacitor is more than just a side project. It's being used in a lot of good places. Folks like Burger King, Blue Cross Blue Shield, and the BBC are making use of Capacitor, as well as smaller startup companies like Sworkit. And this real small company, I don't know if anyone's ever heard of them, IBM. They're using Capacitor as well. So we got a lot of traction so far with companies big and small. So if you're thinking that no one's actually using this, well, we have plenty of people out there that are using this. Now, Capacitor recently just hit its big 3.0 beta release. So everything that I kind of showed you today, the plugins as a different package, some of the install commands, it's all based on our 3.0. And if you go to capacitorjs.com/blog, you'll get access to the release notes and the blog post going over what drove Capacitor 3. So before we hit the Q&A, I kind of want to have some parting thoughts about what it is that we kind of talked about and cross-platform in general. For me, cross-platform is less about write once, run anywhere, but trying to reduce the amount of code that I, as a user, have to write and maintain. Yes, it was great that I could have had that I could write a file system implementation and access it through JavaScript, and that would just work on iOS and it would work on Android. But I don't have to think about what the implementation is doing. I can just know that file system.read directory is going to do the right thing at the right time, and I know that and can be smart about it. We should be able to provide full native access just through JavaScript. There are other approaches to doing this. Some map over the native API and give you full access to it through their API and their type system. But to me, that seems like very counterintuitive, because now we don't have a way to run that in environments where those APIs don't exist. By having this higher level of abstraction around the native APIs and centering it around JavaScript, we can safely type against web, iOS, Android, desktop, even with things like Electron. We can be a little bit smarter about what APIs we are using under the hood and swap out those implementations without developers even knowing it. Also, it's better to have access to a native project than to not have access to it at all. The fact that I could open that up in Xcode, make modifications to the main app delegate, I'd rather have that than not have any access to it at all, or have ways to modify that. So it might seem scary at first, but it's going to be a lot more future-proof to have that there and maintain that in version control than to just say, oh, delete the native project. We don't want to do that. So with that, let's kind of open it up to some Q&A and see what people have been asking. So, we got some questions in here. Awesome. All right. So, Brooke, should I just go at this and start asking these questions?
Yeah, just work your way through it however you see best.
Awesome. Cool. So we have our very first question is, if I build an application with Ionic and Capacitor that uses geolocation and camera, do I need to build it using Android Studio and Xcode to preview the native functionality, or is there some alternative way without installing an IDE? So the actual, let's kind of rephrase it. This was very Ionic agnostic. So Ionic has no impact. Ionic is just the UI. For Capacitor, if you want to make use of the camera and geolocation, we have the geolocation API in the browser. And then we also have a third-party library, well, not third-party, it's still maintained by us, but an optional library called PWA Elements, which will allow you to have access to the camera and some UI to show that just through the web. So yes and no, you could have access to these features without having to install Android Studio and Xcode. But if you want to actually ship that to the App Store, you're eventually going to have to install those. So thank you for that question. The next question, is there any built-in plugin for working with Cloud Firestore and Capacitor, or do I need to install the standalone one from Firebase? So there's different approaches to this. We provide a Firebase API set of plugins for things like their analytics, their crash monitoring service, things that you can do that you want some of the fidelity from a native implementation. But if you're just looking to get things like Firestore or their real-time database or even authentication, the web implementation should be able to suffice for this. I think the best way to think about it is if the implementation depends on some native fidelity, use the plugin, but also note that the web version of it is still valid to be a valid solution to use. So is there any built-in plugin or way of working with it? Yeah, you have the JavaScript library that you can use. For third-party situations, you could also use their Firebase Analytics and Firebase Authentication plugins from the Capacitor community. So yeah, check out the Capacitor community because there's a set of Firebase plugins there. Does Capacitor, is a good one from Dimitri, does Capacitor help in any way to publish your app to the app stores? No, Capacitor itself does not necessarily care about how you publish it to the app stores. I will say a little shameless plug, Ionic does offer a service called AppFlow, which supports Capacitor projects, which will allow you to automate that whole entire process and have a publish to the app store feature. So you could check that out. But Capacitor itself doesn't necessarily, that's not its focus. Let's see, what else do we got? Can ng-serve work with Capacitor so we can develop and test with live reload on a mobile device? I know that if you're using the Ionic CLI, it'll automatically give you a live reload on the device. I haven't actually tested with ng-serve on a standalone, so that is a great question. I'd like to know your name, but it says guest. But what you could do is go to our github.com/ionic-team/capacitor, and we have a discussions panel on there. You could bring this up and we could discuss it there and figure out if this is something that is already built into the CLI, and if not, how can we make this possible? Will the Capacitor APIs work on desktop? For example, the file system API in Electron would make sense to use there, or in an Electron app, and would it make sense to use it there? So Electron right now is in the Capacitor community organization. So if you wanted to add that, it is still a community-based project, which you can totally add and check out. I'm not too involved in it, so I can't say with certainty if the file system API there makes use of the native file system implementation. But if it does have a file system API, it should be able to support that. So I would suggest Danny going to the Capacitor community organization on GitHub, looking up the Electron repo and opening an issue for that so that we can discuss it a little bit further. A really good one from Sean. everything I've read about capacitor batches on Cordova's CLI approach, but a CI environment will require one. How do you address this? So I didn't really talk about it too much here, but there is a way to have Capacitor build and run your project through a CLI. I would say that these are just tools on top of Xcode and Android Studio, or the Android SDK's built-in CLI tools. So for iOS, there's something, I think it's Xrun that you can, or Xcode build or Xrun that you can use to build out your project. And Android Studio has its own approach doing that. So we're not necessarily trying to replace all of Cordova's CLI approach. So for instance, if you were in a GitHub Actions kind of approach, any valid action that builds a native iOS project would still apply here. So you would just make sure that you are picking out, hey, I want to test out my build for iOS, run this action for the iOS platform, and it would work. Eric has a question: does it combine well with NX dev tools for mono repos? Yes, though I will admit that at this point, it's still there's still some work involved to make sure that the experience is as polished as it could be. There is a community project called NX Extend that has a Capacitor plugin for NX that can work in that situation. I haven't tried it myself. I know that one of the maintainers of it works for Ionic, so I can always ask them to figure out if there's anything that people should be aware of. So reach out to me on Twitter. My handle's right there on the screen. Hopefully I'll get an answer for you on that. All right. Can I control what is being compiled to mobile versus web? For example, if I have pages I only want on the web. This is a very good question. I would suggest using, thinking this less as mobile versus web, and thinking of it more in terms of environments, like you would for your Angular environment files or configurations. So you have ng-build and ng-build prod. This is the same, in effect, the same way that you're doing things there. So if you have pages that you want to include for your native project, or only included in the web project, you're essentially just creating a new environment in your Angular JSON and then providing those files to your router setup. So that could be one way of doing that. That would be fairly typical to an Angular developer's experience. Bartos, is it possible to create an iOS capacitor app on Windows? We have no Xcode here. Is it possible with the help of AppFlow? Yes, you could use AppFlow here to handle compiling your iOS binary. As far as I know, still to this day, Apple does not ship an SDK that is that you can run on a Windows device, because Apple being Apple, it's their platform, they control it. But you could use AppFlow in this case to compile the app yourself. Lance, does Capacitor have a plugin for GPS and tracking GPS in the background? I don't know about background tracking for GPS off the top of my head. I would check out the Capacitor community org. There could be one in there. I would also want to point out that background geolocation services are still a very, what's the best way to say it? Iffy subject, especially on iOS. They tend to only allow that for very, very specific use cases. So if you want that, you're going to have to plead your case on why your app deserves that feature. Privacy matters, right? We don't want to be tracked in the background. Eric, another question from Eric. Is there something like this, but for Apple TV with Angular? Off the top of my head, I do not know. In theory, Angular's renderer is pretty abstract, so you could create your own custom renderer for that, but it's a bit beyond the scope for Capacitor and what it tries to do. Are there any plugins available for barcode scanning, built-in, inbuilt, not using the camera? If I'm understanding this, I think it's like a hardware attachment. If you could just clarify in the Q&A, that'd be great. I'm going to assume that yes. So hardware. At the moment, I think we're talking with some of the people who create hardware scanners as like an option for that. So I don't have all the answers at the moment, but we are aware that this is something people want. Yeah, and we're talking to the people who actually manufacture those. So hopefully we'll have something to talk about there in the future. Another question from guest. Without using Ionic Framework or the Ionic CLI, can we use AppFlow and its live update feature with Angular and Capacitor alone? Yes. So all these features of AppFlow are Ionic agnostic, even though we're still very much tied to them. So if you have just an Angular and Capacitor app and you would like to use AppFlow and the live deploy features, it's totally possible to do that without having to change anything. AppFlow should have some documentation about this. More or less, it's just like committing code to version control, and you just set the target to deploy to AppFlow, and then the Capacitor app will read the updates and apply those to your app. So nothing specific to Ionic here. Let's see. Is there any workaround for Square payments? I'm not 100% sure what you mean there. Is there support for Square for things like Square payments? I'm going to assume the hardware potentially. Like the little card reader that you can attach. Not off the top of my head that I know of, but we can always reach out and talk to them and see what they have for an SDK. Cool, answered that one. I have a legacy solution that I used to build with PhoneGap Build. Do I need to install the cap and rewrite parts of the code, or is there any migration process for a smooth transition to AppFlow? Cool. Yeah, there is a transition process. If you go to appflow.com, you should be, or I think it's useappflow.io. If you go to ionicframework.com, you should see a drop down for AppFlow. We have that inside of our docs to show you how to migrate from PhoneGap Build to AppFlow and cover all the details. And if you run into any issues, there's a little support feature in AppFlow to send a ticket to our support team. They should be able to help you out. Is there any specific points that I should be aware of if I want to integrate a WebGL library with Capacitor? Again, no, you shouldn't really. WebGL is a web standard. You're basically just rendering to a canvas on the DOM. And Capacitor is all about the DOM and being able to use your standard HTML and web app approaches. So there shouldn't be anything you should be aware of. It should just work. Are there any helpful tools in creating assets for your app, i.e. the icons and splash screen? Yes, we have a tool, unfortunately named Cordova Res. You can install it npm install -g Cordova-res. It is, let's see, npm -g Cordova res. Yeah, I'll send that to you. It's unfortunately named, but it does have the ability to generate the assets and then copy them over. So if you have like a standard icon file and then a splash screen kind of template, it'll generate all that for you. And there is, I think, a -- no copy or no config flag that you can use to for capacitor projects. And then anonymous attendee, does Capacitor have plugins to convert the web local storage? I'm assuming you mean if you have a web app and you want to access those features from the native app. If that's the case, no, we actually don't, because the web app and then the native app are siloed differently inside of the operating system. So features that would exist or data that would have been stored in the web app, you can't necessarily access them from the native app. So that unfortunately would not be possible. And that's a limitation on just the native platforms, not necessarily a limitation on Cordova. So thanks for that question, chat. Cool. All right. I think that is all the questions. So thank you all for the Q&A. Hopefully, again, if you have any questions that you can think of later, ask them on reach out on Twitter at Hartington. I'm pretty active on there. But thank you all for attending. Apologize for the audio issues going on there, but